Hi, Algebra 2 friends. This week we are going to talk about imaginary and complex numbers and roots. So I know that sounds a little bit daunting, but it's actually not too bad, I promise. Okay, so first of all, what is an imaginary number? An imaginary number is a square root of -1. So in the past, you've always been told you can't take the square root of a negative number. Well, that's because there's no real solution. Because we know that when we take the square root of something, say 25, okay, the answer could be 5 or -5. And the reason is 5 squared is 25, -5 squared is also 25. But -25, the only way we can get that product is if one of our two numbers is negative. So notice they are not the same. So what we can do is we can factor out what we call I, our imaginary unit. Okay, so let's look at this chart. So I is what we call the square root of -1. It is an imaginary number. Okay, the imaginary unit or number can be written as a product of two numbers, or we'll see in a little bit, it can also be added to a real number to create a complex number. Let's do a few examples together of simplifying expressions that involve the imaginary unit I, and I think you'll see you can get the hang of it pretty quickly. So, example A, I see 5 times the square root of -121. Well, remember we just said that the square root of -1 is equal to the imaginary unit I. So I'm going to break this down into the square root of -1 times the square root of +121. So now I have three parts. I've got my 5, my multiplier, the square root of -1, and the square root of 121. I'm going to write down 5. When we see the square root of -1, we write I, and then the square root of 121 we know is 11. We're going to go ahead and simplify this by combining our like terms, and we get 55i. Just like when we're working with variables such as x and y, it's best practice to put the multiplier in front of the I. Let's take another one. So right here I see this negative sign. It's on the outside, so I'll deal with that later. But I can break down this square root into the square root of -1 times the square root of 96. Whenever I see the square root of -1, that means I write I. So I'm going to come over to the right. I've got -I square root of 96. Now 96 is not a perfect square, so I'm going to grab my calculator because I bet there's some perfect squares that go into it. So I'm going to do some guessing. 96 divided by 16 is my first guess, and I guessed right. 96 divided by 16 is 6. So let's break this down and simplify it further. The square root of 16, square root of 6. And so this simplifies to, when I take all of these parts, I've got my -I, the square root of 16, and the square root of 6. So the square root of 16 is 4. -4i square root 6. That's my simplified expression. Now, if you're having a hard time remembering how to simplify square roots like this, we did that the first or second week of the school year. So you can go back through our Algebra 2 playlist. You'll find it at the very, very bottom, and you can rewatch those videos. Okay, what we're going to look at next is how we can incorporate this into solving quadratics. So I'm going to go ahead and stop this video here, and we'll pick up the next one with solving quadratics that have imaginary or complex solutions.